Hello everyone, welcome back to my Cellchat video tutorial. Today I'm going to show you how to visualize the cell-cell communication networks. So first let's load the package Cellchat. So we saved the Cellchat object we analyzed in previous videos. So we can load in the Cellchat object. First, let's have a look how many significant pathways we identified from this Cellchat object. So we can just run this code for the pathway. You can see we identified 47 cell-cell communication networks in this Cellchat object. Cellchat has a function called extract enriched ligand receptor pairs. Using this function, you can reveal all the ligand receptor pairs. And also if you set the gene ligand receptor return is true, you can also see how many genes are there. So if we run this code, you can see there are 143 ligand receptor pairs, and also in total there are 190 genes. So now we know how many signaling pathways are there and the individual ligand receptor pairs. So next we can visualize the contribution of each ligand receptor pairs to the overall communication networks. So you can use the net analysis contribution function to see the contribution from each ligand receptor pairs. So let's run this function. You can see we generated a plot to show the contribution from each ligand receptor pairs. Because we have 143 ligand receptor pairs, so here is too crowded, we can export to PDF. We can change the settings to make a larger plot. Then we can preview all the ligand receptor pairs. You can see here we have 143 ligand receptor pairs, and the strongest contribution is from the MIF signaling pathways. So if you don't want to see all the ligand receptor pairs, you can also set the pathways that you want to plot. For example, we can just plot the contribution for the first 5 signaling pathways. They are MIF, galactin, CXCL, IL2, and the complement signaling pathways. If we plot the contribution for the ligand receptor pairs from the first 5 signaling pathways, you can see we have a plot to show the contribution of each ligand receptor pairs from the first 5 signaling pathways. You can also plot the individual signaling pathways. I showed you we have 47 signaling pathways. So I'm going to use TNF signaling pathways as an example to show you how to run individual signaling pathways. So first we can extract the enriched ligand receptor pairs for the TNF signaling pathway. You can see for the TNF signaling pathways, there are 2 ligand receptor interaction networks. One is the TNF through the receptor 1A network, and the other one is for the TNF through receptor 1B network. So we know there are 2 ligand receptor pairs in the TNF signaling pathway. So we can use the net analysis contribution function to see the contribution from each ligand receptor pairs for the TNF signaling pathway. So you can see TNF through receptor 1A has the strongest contribution to TNF communication network in this Cellchat object. There are only two ligand receptor pairs in the TNF signaling pathway, so we can use another signaling pathway as example to show you the same plot again. We are going to use CCL signaling pathway. You can plot any signaling pathways from the 47 signaling pathways. So let's extract the enriched ligand receptor pairs for the CCL signaling pathway. You can see we have 5 ligand receptor pairs, CCL5 interacting with the CCR1 and the CCR5 receptor, CCL2 through the CCR2 receptor, CCL4 through the CCR5 receptor, and CCL19 through the CCR7 receptor. Then we can see the contribution of each ligand receptor pair for the CCL signaling pathways. You can see CCL5 through the CCR1 has the strongest contribution to the CCL signaling pathways in this Cellchat object. So in my video 3 at the end, I show you how to use the circle plot to plot the aggregated signaling pathways for this Cellchat object. So now I'm going to show the circle plot again for the individual signaling pathways. Once again, we are going to use the TNF signaling pathway as an example. So we can plot the aggregated communication network for the TNF signaling pathway by the circle plot. Let's zoom in to see the communication networks. You can see the Cellchat object has 12 cell types. There are 4 different fibroblast subtypes and 8 different immune cell types. You can see from the communication network, TNF are produced by the immune cells and largely interacting with the receptor on the fibroblast. The strongest interaction are from the CD40LG positive T cells and the T cells to the inflammatory fibroblast, FBN1 positive and ApoE positive fibroblast. So you know there are 2 ligand receptor pairs in the TNF signaling pathway. We can also plot the individual signaling pathways. Let's zoom in. You can see on the left, we use the circle plot to plot the TNF signaling pathway through the 1A receptor, and on the right is the TNF signaling pathway through the 1B receptor. We know from the contribution plot already, the strongest contribution is through the TNF1A receptor. So you can see much wider arrows in the left side plot. The width of the arrows indicates how strong the interaction is between different cell types. So here we plot both ligand receptor pairs. If you are only interested in one ligand receptor pairs, you can also set the pair ligand receptor used as receptor 1A or receptor 1B. And here I'm going to use the TNF receptor 1A ligand receptor pairs as an example to plot the 1 signaling pathways. you can see now we only generate a plot for the TNF interaction with the receptor 1A for the circle plot. Next, I'm going to show you the chord plot. Once again, we are going to use the TNF signaling pathways as our example. First, let's set some parameters for the plot. Then we can use the net visual aggregate function to see the aggregated network for the TNF signaling pathways. We can zoom in to see the plot. You can see the chord plot. The outside circle indicates the cell types. We have 12 different cell types in this object, and the length represents how many cells in each cell group. The length is longer means that there are more cells in this cell group, and the circle inside indicate how each cell type interact with other cell types, and the cell types are represented by their color. You can see we know from the circle plot, TNF are largely produced by the immune cells. They interact with the receptor expressed on the fibroblast. The chord plot function also can plot the cells or genes. If you use the net visual chord cells function, it will produce the same plot as the net visual aggregate. So let's clear the plot first. Then we can use the net visual chord cell function. Okay, the plot is quite small. Let's set the parameter again. And we can plot the net visual chord cell function again. You can see now we have the same chord plot as the net visual aggregate function. But if you plot the genes for the TNF signaling pathway, use the chord plot, you can see we generated a plot here to show the genes in TNF-alpha signaling pathway. Because the plot window is small, we can zoom in to have a better view for the genes. You can see on the right hand side we have the color represent 12 different cell types. Because now we plot the genes, so will be TNF ligand interact with receptor 1A and 1B. So you can see the chord plot leave two empty space to separate the ligand and the receptor. On the bottom side, there the immune cells produce TNF ligand. On the top side, there are the fibroblasts to express the 1A receptor and the 1B receptor. You can see the strongest interaction are from the immune cells to fibroblasts. There was a very weak interactions from the immune cells to the immune cells. So you know we have different cell types, the fibroblast, immune cells in this Cellchat object. We can group the cell types and use the chord plot to show the interaction again. We know there are 4 subtypes of fibroblast, 4 subtypes of dendritic cells, and 4 subtypes of T cells in this dataset. So we can group them as fibroblast, dendritic cells, and T cells as 3 groups. Then we can get the cell identity from the Cellchat object. Let's set the plot parameters again. Now we can plot the cells as the groups we set here. We can zoom in again. you can see now there are 3 gaps on the chord plot. You can see here are the 4 fibroblast subtypes, and here are the 4 dendritic cell types, and here are the 4 T cell subtypes. Once again, you can see TNF are largely produced by the T cells and dendritic cells. It interacts with the 1A and 1B receptor on fibroblast. At the moment, we are plotting the overall signaling pathways between all the cell types. If you want to generate a plot for one cell type interact with the other cell types, you can define the source cell types and the target cell types. For example, we can plot the genes for the cell type 4 interact with cell type 5 and 6. Here we are going to plot all the signaling pathways between cell type 4 and 5 and 6. So let's plot the genes. So we generated a plot here. We can zoom in. You can see we have 3 cell types here now. Cell type 4 is the inflammatory fibroblast. And you can see we only have 1 source cell. And the target are dendritic cells, cell type 5 and 6. You can see on the bottom side, all the ligands from the inflammatory fibroblast interact with the receptors on dendritic cells. So we can change the cell source. For example, we are going to use the source cells as 1, 2, 3, 4, and we know there are 4 fibroblast subtypes, and the target cells we are using number 8. If we plot the interaction between fibroblast to target immune cells number 8, you can see we generated a new chord plot. Let's zoom in again. Now you can see we can see the expression for the ligand from 4 fibroblast subtypes. They are ApoE positive, FBN1 positive, collagen 11A1 positive, and inflammatory fibroblast, and how the ligand interact with their receptors on the inflammatory dendritic cells. You can see because there are lots of interactions here, it's really hard to see the gene names on the plot, because here we plot all the interactions from fibroblast to the inflammatory dendritic cells. We can just plot the signaling pathways now we are interested. So I'm going to use the CCL and the CXCL signaling pathways as an example to plot the communication networks from fibroblast to inflammatory dendritic cells again. You can see the new plot. Let's zoom in again. You can see now, because we only plot the CCL and the CXCL signaling pathways between the fibroblast and the inflammatory dendritic cells. So now you can see the fibroblast expresses CXCL12, CCL4, 5, and 19. They interact with the receptor CCR7 and CXCR4 on the inflammatory dendritic cells. I only use some cell types and also some signaling pathways to show you how to do the plot. You can choose any cell type, any signaling pathways you are interested to practice the plot. So far I showed you the circle plot and the chord plot. Next I'm going to show you the hierarchy plot. For the hierarchy plot, we need to set the cell groups on the left side. For example, we know the first 4 cell types are fibroblast. Then we can set the fibroblast on the left side. Then we can generate a hierarchy plot for the TNF signaling pathway. So let's generate the plot first, then we can explain the interactions. So you can see we have the hierarchy plot in our plot window. Let's zoom in. You can see we have 2 hierarchy plot for the TNF signaling pathways. Because we defined the left side as 4 cell types, they are fibroblast. You can see on the left hand side we have the source cells as the fibroblast, and the target cells also are the fibroblast. They are represented by their color. Then on the right hand side we have the rest cell types. We have 8 immune cells. From previous plot, we know the TNF signaling pathways are largely through the immune cells to the fibroblast. You can see on the left hand side plot, we have strong interactions from the immune cells to the fibroblast. On the right hand side plot, the source cells are still fibroblast on the left. And then the target cells now are the remain cell types. They are immune cells. Then we can see how immune cells interact with immune cells through the TNF signaling pathway. You can see from the width of the arrow, the strongest interaction are between immune cells to fibroblast. So here, we plot the aggregated TNF signaling pathways. We can also plot the individual ligand receptor pairs. So I'm going to use the CXCL signaling pathway as the example now for the individual ligand receptor pairs. To plot the individual ligand receptor pairs, you need to use the net viewer individual function. So we're going to set the signaling pathways as CXCL signaling pathway because we just want to plot one signaling pathway. For example, we are going to use the ligand receptor pair between CXCL12 and the CXCR receptor for the hierarchy plot, and we still use the same settings for the vertex receiver. That means we are going to plot a fibroblast on the left hand side. So let's generate the plot. We can zoom in. You can see now we only plot the CXCL12 interaction with CXCR receptor. You can see on the left hand side we have the fibroblast as the source. On the left hand side the target are fibroblast, and the immune cells are on the right hand side. On the right hand side figure we still have the fibroblast on the left hand side, immune cells on the right hand side. Now the target are the immune cells. You can see the CXCL12, CXCR signaling pathways are largely mediated by the ApoE positive fibroblast, FBN positive fibroblast, and inflammatory fibroblast to the dendritic cells and the CD40LG positive T cells. So I explained to you how to use the hierarchy plot. You can also generate the Heatmap and the wiring plot for the Cellchat object. We can use the TNF-alpha function again to generate the Heatmap for the interactions. We can zoom in. You can see the Heatmap for the TNF signaling pathways in this object, we know the interaction is largely between immune cells with the fibroblast. So you can see from the corner, the interaction is largely between dendritic cells, T cells with fibroblast. You can also use the wire lymph node to show the expression of TNF and its receptor 1A and 1B in different cell types. So in Cellchat, this function is named as PNOT gene expression, but it will generate a wire lymph node. So you can see we generate a wire lymph node. We can zoom in again. You can see we have 12 cell types. The color matches to the cell types on the right hand side. The first 4 are fibroblasts. You can see TNF is largely expressed by the immune cells, and we know the strongest interaction are between TNF and 1A receptor. You can see high expression of 1A receptor in the fibroblast. So in this video, I'm going to show you one more PNOT function, the bubble PNOT function in the Cellchat package. The bubble PNOT function is useful to show multiple ligand receptor interactions. For example, we can use the bubble PNOT to show the interaction between the inflammatory fibroblast with all the immune cell types. So let's generate the PNOT. Because there are lots of interaction once again, here it is very crowded in this PNOT. We can export it to PDF again. Let's change the settings. We can change it to 7 and 20. Then preview. So you can see the interactions between the inflammatory fibroblast to 8 immune cell subtypes. So there are lots of interactions here. You can see, and the color from blue to red indicate how strong the interactions. We know from the contributions the MIF signaling pathway has the strongest interaction between fibroblast and the immune cells. Here we show all the interactions between inflammatory fibroblast with 8 different immune cell subtypes. If you are interested just for some signaling pathways, you can change the settings to just promote the signaling pathways you are interested. For example, we can still promote the interactions between inflammatory fibroblast with 8 immune cell types, but we can focus on the signaling pathway we are interested. So I'm going to use the CCL and the CXCL signaling pathway as an example again. You can promote any signaling pathways you are interested, because we have 47 signaling pathways in this Cellchat object. So let's generate the plot for the CCL and the CXCL signaling pathway. Now you can see from the plot for the CCL and the CX signaling pathways between the inflammatory fibroblast with 8 immune cell subtypes. You can see the strongest interaction is the CXCL12 ligand with the CXCR4 receptor, and also the CCL19 interact with the CCR7 receptor between inflammatory fibroblast and the inflammatory dendritic cells. Okay, in summary, for today's video tutorial, I showed you how to use the different plot function in Cellchat package to produce images for your publication or presentation. I only used some examples, but through the tutorial, I hope you understand how to change the settings to promote the signaling pathways and the cell types you are interested for your research. So that's it for today's tutorial. I hope my tutorial could help your data analysis. Please subscribe my channel if you are new to the channel, and also share my videos with your friends. Thank you and see you next time.